Now ABC brings you the stories you never knew. Motown 40, ABC Sunday.
Prime Time continues. Now from New York, Diane Sawyer.
Again and again, American students are given tests comparing them to students in other countries. And the pattern has been that students here lag behind their foreign counterparts in subjects like science and math. The follow-up question, of course, is always why? Well, Primetime found an expert who says he knows the answer and that a few simple changes in the American approach could make a world of difference. And not only that, he can show you on videotape. Cynthia McFadden sat down to see if we could help solve the puzzle.
90 plus 90 is...
Are we solving for 2x or are we solving for
multiplied by pi?
Circumference divided by diameter.
Triangle ABC
Equal 180 degrees.
Numerical example of a zero exponent.
The U.S. and more than 40 other economically advanced countries tested their students in math and science to see how they scored and how they compared.
There's a report today which states that in two critical areas, math and science, American students do not match up very well with other students in other countries.
The results show American schools are failing the test.
I think the most telling aspect of this is there were only 7 countries that we can say that we actually outperformed. And
7 countries in the world that we outperformed?
Yes.
That's it in math?
That's correct. It's Lithuania, Cyprus, Portugal, Colombia, South Africa, Iran, and Kuwait.
Bill Schmidt helped design the test, the largest of its kind ever. But even he could never have imagined that not only would the overall U.S. scores be so far down the scale, but that our top students would only be average in some countries.
This is really about something very serious. Our children are at risk here, and I think that's the wake-up call.
2 times 2 times 2 gives you 8.
The question is, what to do? Why do kids in countries like Singapore, Korea, and Japan outscore U.S. kids so badly? It's not for the reasons you probably think. When the researchers looked more closely, they busted a lot of stereotypes. Class size, they found foreign kids even more jammed in than Americans. Fancier schools, they saw lessons conducted in buildings in worse shape than ours. Harsh discipline, slavish studying. How about these Japanese 8th graders laughing during math class?
So, less TV, more homework, school uniforms, more passion, better teachers, that's not it.
Not likely. No. It's really about what we teach and how we teach it.
What do you notice about this graph, though, how it changes?
We just teach our mathematics especially so differently from much of the rest of the world.
What we teach and how we teach it. It sounds so simple. But listen to how Julie Nelson, a good student from Minnetonka, Minnesota, describes math.
It's kind of a set in stone. It's a procedure. It's a formula. You learn the formula and you know how to do math.
Do you want the negative to go with your exponent?
Schmidt says the way Julie is taught is pretty much the same as any classroom in the country, like this one.
What is this angle called here?
A straight?
Straight angle.
This seems like the same kind of thing I learned in Auburn, Maine.
Yeah, a lot of people say, that's my math teacher.
UCLA professor Jim Stigler videotaped hundreds of hours of classroom teaching across the United States and compared it with hundreds of hours of classroom teaching in Japan. Now, for the first time, you can clearly see the dramatic difference.
When you look at the videotapes and you see what they're doing and how they're doing it, it makes sense that they would learn more. Instead of the teacher starting by showing you how to do something, he starts by giving you a problem. And then he just hangs a sign up at the top that says, think.
Think?
That's what it says, think. They're constantly telling students, think, think, think.
In class after class on the Japanese videotape, Stigler says teachers asking students to think on their own, pondering a way to solve a problem without the teacher having told them any formulas or rules to use. 10 or 15 minutes later, they've either figured it out or they've become frustrated trying. But even that's good, part of their learning process. But not ours.
What is the rule for power of a fraction? Power of a quotient?
The idea is memorize the rule.
There's a lot of rules. You got to remember all the rules, and then you know math.
What do we call that?
On the U.S. tape, Stigler says in class after class, there's a lot of rules and little else.
If I take the number of sides and I subtract 2, and I multiply that number times 180 degrees, that will tell me how many degrees these add up to.
I didn't get that.
That's...
How many sides?
I bet they didn't either.
How could they? When you think about it.
Are you saying this is a bad teacher?
No, this is not a bad teacher. This is a typical American teacher. Actually, this is a good teacher. This is a teacher who is doing a very competent job of teaching like a typical American teacher.
A typical American teacher.
Let's look at it together then.
Who believes that the first sign of confusion,
Let's show you this, okay?
the teacher steps in.
She's taking the pencil out of his hand.
Right. Okay. Yeah. Well, she's trying to help him get through those steps.
But in Japan, it's the concept behind the rules.
He did figure this out, but he's not exactly sure how to explain it.
Even when a student is confused, it's believed he will end up understanding more if he tries to explain his thought process to the class.
Now the teacher is going to give his explanation, but by now everyone's ready to hear it. That's the key.
Well, not just ready, but unlike in the American classroom where you're sort of going, all right, explain it. They want to know because they've suffered through not knowing.
Exactly.
Do you know what angle B is?
And it's not just how we teach, it's what we teach. So many topics, U.S. teachers can never concentrate on any one thing for very long.
What happens is we never get past that very superficial sort of knowledge all the way through. We just have this, we call it the mile-wide, inch-deep curriculum. This is a U.S. mathematics book, 8th grade level, okay? And you can see it is about 700 pages long. They're built like an encyclopedia. It's a big book. The rest of the world are carrying books around that look like this. This is the 8th grade Japanese curriculum. As you see, they're paperbacks. They're small.
That's a textbook?
It. These two combined is the equivalent to this.
And they end up knowing more than we do.
And they end up knowing more than we do. And it's not just Japan, like these books. Right. Look at this book. This book is from Slovakia, another very high-achieving country. That's their 8th grade math book. Here's a Russian textbook. It's the same. It's a small, straightforward book.
Russia, Slovakia, Japan. Schmidt says any teacher can get into more depth, covering 5 or 6 topics a year in the smaller books, rather than the 35 or so in American textbooks.
I wouldn't want to say blame the teachers. It's bad teachers. It's a bad system.
You need to write a procedure in your group.
But before you say that's the American way, take a look at Julie Nelson's science class back in Minnetonka, Minnesota, where the teachers themselves have come up with a different kind of system.
I want you to come up with your group, come up with an answer. We haven't talked about it in class yet.
Answers before you talk about something? Working in groups? Sound Japanese?
What do you think of that answer? Sound plausible?
Minnesota offers the nation generation hope. It says, yes, we can do it, and it says, here's an idea of what we have to do in order to do it, in order to be number one.
If math in Minnesota is taught like most of the country,
Come on up, send one up, person up.
science is taught more like the rest of the world. Fewer topics done in more depth.
Are the crystals random or layered?
It's those fewer topics that's the key, not the Japanese style. Mike Rogers is using his own technique, and with fewer topics to cover, teachers have the time and the freedom to do whatever they think is necessary to make sure kids are learning.
You tend to find that when you can go into more depth, kids make more connections. Instead of just memorizing information, they start to understand the connections between them.
The results speak for themselves. With essentially only this difference in teaching, the same kids in Minnesota who did so-so in math on the international test skyrocketed in science. In one category, they tied for #1 in the world.
We don't want to be simplistic and think that if, in fact, we only changed teaching, that our students would learn more. They may not. But you know what? It makes a lot of sense that they would.
We can't wait around. We're not where we want to be. We have to do something, and we have to do it now.
Of course, there are so many social variables that are part of this equation. No one is suggesting that we import another country's education system to the U.S., but researchers do suggest we look around the world for ideas that we can Americanize into something workable for students here.